Okay, today up on the bench we have probably one of my favorite AM only CB radios. This is the Sonar FS-2340. This style of radio came in three different models. The original FS-23, that was preceded by the FS-3023, and then finally when 40 channels came around, they basically took the exact same radio, did a few modifications to it, and turned it into the FS-2340. Two big differences between this radio and the previous two. The first two were pretty much the same, few minor differences, but overall there's not really a huge difference between the 23 and the 3023. But there are two big differences between those two and this one. The first, of course, this is a 40-channel radio. It's no longer uses a crystal mixing circuit, so it doesn't have a huge channel selector switch on the inside with two rows of crystals. They went to an early, I guess you could call it an early PLL circuit, made up of several components. It's not like your modern day radio where they have just a PLL chip and a little bit of supporting components. This has two separate circuit boards. Much like many of the other tube-type radios of this same era, when they switched over to 40 channel, for the people that still wanted tube-type radios, so like some of your T-Berries, the Robin, if you're familiar with the old 23 channel, the green Robin, and then they came out with the yellow, some of those people call it the yellow bird, the 40 channel. They basically did the same thing they did in this. They took out their channel selector switch and crystal board, tossed it in a trash can, designed up a double board, because in those style radios also they did the same thing. There's double circuit boards, and put a LED display in it. But otherwise, pretty much the same in those radios. In this, and they've removed the oscillator tube. Now in this radio, they did something that made this a stellar. It took a good sounding radio and turned it into an absolutely stellar sounding radio on as far as transmit audio goes. And what they did is they took the original circuit for your modulation, which in the original 23 and 3023s was a single tube. It used a dual element tube for modulation, which was a 12BH7, and they've replaced that with two individual 6BQ5 tubes run basically in push-pull. So they took the, a kind of anemic, which actually it was fine, don't get me wrong, I shouldn't say anemic, that's not the right word, because if they were good sounding radios, the 23s and 3023s, there's nothing wrong with them, but they took a good sounding radio and turned it into this, which could, basically compete with like a Tram D201 or the Brownings. It took a good sounding radio and gave it some audio, just really good audio punch. So, if we look at that on the schematic, here we have, and these two manuals are actually factory original manuals. So, if we look at these, so here's the, what's this one? This is the 3023. So we can see, here's the modulation audio output, and you can see they just used a single 12BH7 dual element tube, and they're using both elements of that tube for modulation and audio, also to your speaker as well. And then the earlier version, the FS-23, basically exactly the same. Same thing, 12BH7, using both elements, out to either the speaker or for modulation. And then we have the 2340, which if we look down here, is the camera going to focus on this? Maybe. We can see the single tube has now been replaced with two separate 6BQ5 tubes. So the radio now has three 6BQ5s. It has one for the RF final output tube and two for the audio modulation. So just has gobs and gobs of more available modulation power, basically. So like I say, turn a good radio into a screamer. It's probably the easiest way to put it. But, so I'm probably going to do 2 separate videos on this radio. The first video, which is this one, is going to be on the PLL circuit, or the synthesizer circuit, and the common problems, or common problem you will see with these. Now, in a later video, because this one's getting restored, hasn't had anything done to it yet, so all the electrolytic capacitors need to be replaced. So it will be completely blown apart, the top and bottom covers taken off, the side panels, and you'll get a good view of the inside. But for right now, you're going to see the outside, and then the next thing you'll see is going to be the channel selector board and PLL board removed out of the radio. But the problem you'll see, if you ever have a radio, it's working one day and it's not the next. And you happen to notice something, and that's something you're going to notice. Now, I have already turned this on, brought it up slowly on a variac just to make sure it's, nothing was going to explode on me, and that's fine. So if we turn it on, you see something that should not be there. And what should not be there is that decimal point. And with that decimal point, what these radios do is, if the PLL circuit goes out of lock, that's exactly what happens. It illuminates that decimal point. So a normal operating radio would not have that decimal point. So without any diagnostics, we know exactly what the problem is, why this radio won't do anything. The PLL's out of lock. So the first thing we're going to do is very simple. That's to recap it, or replace the electrolytic capacitors on it. In my opinion, probably, I don't know, somewhere between 70 to 80% of the 2340s that I see that have an out-of-lock PLL, where that decimal point is illuminated, it's a bad electrolytic capacitor. But there's no guarantee. Like I say, that's probably 70 to 80% of the time, which is a pretty good chance. You're getting around 3/4 of the way there. So that's the first thing we'll do. We'll do that, and we'll see if we can get that annoying decimal point to go away, and get transmit and receive to come back. So give me a minute to get all that get it torn out, and I'll let you see what it looks like. Okay, so you can see it has been removed. It's fairly simple to get out. Like I say, completely blow the radio apart, so top, bottom, and side covers, because you want this front to be able to flex a little bit. What you will find is there's 2 screws come up from the underside. Okay, just like this. A star washer and a flat washer. Remove those. Those are what come into the back side of this from the underside. Then take your knob off. There's 2 Allen head screws that hold that on. 3/16 Allen head set screws. Loosen them, take your knob off, and there's 2 screws behind that. Now I always suggest taking those out first, because if you take these 2 out first, then stand the radio up on its side and take those 2 rear ones out, then the module is going to flop out. So take those 2 out first, set the radio back down, then take the 2 front ones out. Then the module just lifts up, but you will have to flex the front a little bit to get this bracket, because it's going to rub up against this transformer right here, and just pull it up and out of the radio. Very simple to unhook. That's it. You're looking at it. A coax cable and 1 wire. That's the power wire, because this operates off low voltage DC. So it's a completely self-contained module, which is nice because we can diagnose it out of the radio. So all you need to do is unhook the coax cables and they're pins and sockets. So just unplug those from those 2 terminals, and then the supply off this terminal on the back, and you now have the module in your hand and can repair it out of radio very easily. So let me get this out of the way, and we'll get into taking a look at her. Well, without a doubt, this was absolutely the easiest Sonar FS-2340 PLL module repair I've ever had to do. Now I am going to tear it apart and replace all the electrolytic capacitors, but there's nothing really electronically wrong with it. There's just something physically wrong. And that something that's physically wrong is this little red wire right here. It's broken off of the circuit board. That's all it is. So you can see it's turned on. Okay. These run off of 17 volts, so I turn that up just a hair. So there. We have it hooked up to 17 volts, just the ground going to the steel mounting bracket, because that's where it actually gets its ground from, is through that's the chassis. And then the hot wire to that pin where the orange and white wire was that you pulled off. Now, all I have here is this double test clip here. One end goes to the other end where that red wire actually hooks up, and the other end I'm going to hook up to where it's broken off of, and watch the display. And actually, if you look over to the oscilloscope, you'll see I had the scope hooked up to the ground and output pins on here, and there's absolutely nothing on the scope. And if we come back over here and I connect that, notice the decimal point just disappeared. So, decimal point, no decimal point, decimal point, no decimal point. That's all that was wrong with it. And if we now look over at the oscilloscope, aha, look at that. We have our 21 megahertz signal coming out. So, if I change channels, watch the frequency, you'll see it changes. So actually, let me go to channel 1 and channel 40. There you can see a big difference there from 1 to 40. But, yep, that's all it was. Just that simple. Broken wire. So, sorry guys, no detailed troubleshooting procedures on how to troubleshoot the module on this one, because it turned out just a broken wire. So, there you go.